Okay, so let's look at problem number 2. And we're given x is uniform in the interval a to b inclusive and y equals x squared. And now we need to find and draw the probability density function uh, of x and the cumulative probability of x. So if x is uniform, that means the probability from A to B, no matter where x is, as long as it is within A to B, then they'll all just be equal. And also, if we integrate this probability density function, then we'll eventually have 1. So this is to say this is a rectangle that is of length b minus a, and then height of pretty much just b 1 over b minus a, right? So only in this case, when the length times the width, that gives us 1. So very easily we get the probability density function is 1 over b minus a when x is within this interval from a to b inclusive, and otherwise we get 0. And the cumulative probability is also pretty easy. So this is pretty much just a horizontal line. Right. And then we'll just have, if we're outside this interval, if we're left of A, then we don't get anything, right? So the probability will be 0. If we are in the middle of A and B, between A and B and somewhere, we can, so if x is here, then it would be like this tiny little square rectangle area. And this area would be the width 1 over b minus a times the length here, which is x minus a. So that will give us this value here, x minus a over b minus a, when x is within the interval a and b. And if we go over b, then we'll just get the entire area of area, yeah, which is 1. And the second question is for us to find the probability density function in terms of y, given that a is minus 1 and b is 3. And so first of all, we can draw a little graph here, and then we can see this is the graph, and the y-axis is here, and x-axis is here. So if y is less than 0, then the probability density function is 0, because y cannot be 0. Y cannot be below 0. And if y is bigger than 0, bigger or equal than 0, then we have to kind of divide this interval from minus 1 to b a little bit, because so from 0 to minus 1 and from 0 to 1, we have like this symmetric interval. So if we integrate this probability density function in terms of y, we actually are summing these two parts together, right? So we can just take a look here. If y is from 0 to 1, then we actually have two different parts. So respectively, the negative part and the positive part, from -1 to 0 and from 0 to 1. And so we have uh, 2, because 2 parts times 1/4. This is 1 over b minus a, and that is 1/4. This is a constant number because we're given b and a, and the distribution of x is uniform. So we have this 1/4 here, and then this would be the derivative of the square root of y, right? So pretty much this is y to the power of 0.5, and then we'll just have this as its derivative. And eventually we have 1 over 4 times the square root of y. And if y is between 1 and 9, then there's only when x is larger than y and larger than 1 and less than 3. It will only have this interval to correspond to when y is bigger than 1 and less than 9. So right here we no longer have the 2. We only have this 1/4 times, this is still the derivative, and that gives us 1 over a times square root of y. And we can draw a little graph here. Yeah. We can draw a little graph here, and we can see this is the final answer. And then we're also asked to find the cumulative probability of y. So pretty much we need to integrate this probability density function in terms of y, and then we have this. And we need to also find c, which is a constant. So the transition point, so from the left of 1 and from the right of 1, they need to eventually meet at the same value here, which is a half. And so we have c is equal to minus 1/4. And so we'll have this value. When y is between 0 and 1, we have square root of y over 2. Otherwise, from 1 to 9, we have square root y minus, square root of y over 4 plus 1/4. And lastly, we're asked to find out the expectation of y. And we can just have it here. Yeah, because we're asked to find y, then we move y in here and then integrate this thing. And remember, we have 2 different intervals. They're different here and here. So yeah, we'll have this result. Eventually we have an answer of 7/3.